So in this question, we're told that f of x equals minus 3x cubed plus 8x squared minus 9x plus 10. And the x is a real number, which is what this means. Now we need to calculate f of 2. Well, this is pretty straightforward. So if we have f of x, we're trying to find f of 2. So we replace our x's with 2's. So we have minus 3 times 2 cubed, as that's where x is, plus 8 times 2 squared, as that's where x was, minus 9 times 2 plus 10. And plugging this into your calculator, you realise that this actually gives you 0. So that's it for the first part of A. However, let's go to the next question here. We need to now write f of x as a product of two algebraic factors, as it says in the question. So, if x equals 2 gives f of 2 equal to 0, then that means that x minus 2 is a factor by the factor theorem. So consequently, that means that we can already factorize f of x as x minus 2 times, now we don't really know what this inside bit's going to be, but let's just let it equal random letters for now. We'll get back to that in a second. So we know that this is going to be quadratic, because we'll have ax squared plus bx plus c. We know this is going to be quadratic in here, because if we do a cubic divided by x minus 2, then we've reduced the power by 1 everywhere, which means the cubic will now turn into quadratic. If we double check this, as if we try and find the highest x power we can make, will just be this x times by ax squared, we'll get with something cubed, so we know that this makes sense. But now the question becomes, what is a, b, and c? Well, we know that we factored f of x out, but this still equals minus 3x cubed plus 8x squared minus 9x plus 10. So now what we can do is we can compare coefficients. So, in terms of the x cubed coefficients, we know we're going to have x times ax squared there, which says x cubes will have an a x cubed on the left hand side, and on the right hand side we have a minus 3 x cubed. So therefore a is going to be minus 3. Now this is the same thing with x squareds. Now what are all the ways we make x squared on the left hand side? Well, we'll have x times bx, so we'll have a bx squared. And we also have a minus 2 times ax squared, which will give us minus 2a. And this is going to equal the x squared on this side, which is going to be 8. And therefore b is going to be 8 plus 2a. We know a is minus 3, so b is going to be 8 plus 2 times minus 3, which is 8 minus 6, which will give us 2. And lastly, let's just compare, let's skip x and we'll go straight to constants. So we'll go to, let's call the constants k. And so we're going to have minus 2 times c. That's going to be our only constants on the left-hand side. And on the right-hand side, we have a plus 10. Now dividing both sides by minus 2, we see that c is just going to be minus 5. And now, we successfully factorize this, as we just plug in these unknown constants into that, which means that f of x as two algebraic factors is going to be x minus 2 times a, which is minus 3x squared, plus bx, which is plus 2x, plus c, which is minus 5. And that's it for this part of the question. So in terms of the marking, you'll get 1 mark for finding out that f of 2 is 0. And you'll get 1 mark for finding out both of these coefficients, x squared and the x, and you'll get 1 mark for finding out the constant, for a total of 3 marks for this question. So now that we're finished with part A, let's move on to part B. Using the answer to part A, part 2, prove that there are exactly 2 real solutions to this equation here, minus 3y to the 6 plus 8y to the 4 minus 9y squared plus 10 equals 0. Well, first, what did we have from part A, part 2? We said f of x, which is minus 3x cubed, plus 8x squared minus 9x plus 10, can be factorized as x minus 2 minus 3x squared, sorry, minus 3x squared plus 2x minus 5. The first thing to notice is that this equation here f of x is the same equation as this equation here, except we use substitution x equals y squared. So if we take this equation here, minus 3 y to the 6 plus 8y to the 4 minus 9y squared plus 10 equals 0, and we can use the substitution that x equals y squared, then we're left with minus 3x cubed plus 8x squared minus 9x plus 10 equals 0, which is the same thing as f of x. So we can factorize it the same way. So we have x minus 2 minus 3x squared plus 2x minus 5 equals 0. Now we know one of the solutions to this, which is going to be this one here, which is that x equals 2. Now if x equals 2, we know x equals y squared, then that means that y squared equals 2, and so y equals plus or minus root 2 for this equation here. But now we also need to show that those are our two real solutions, which is what the question asks for there. However, we need to now show that this quadratic has no solutions. Now to show a quadratic has no solutions, we need to show that the discriminant, i.e. b squared take 4ac, is less than 0. As if that's the case, then the quadratic will have no real solutions. So taking this quadratic and plugging into here, b squared is going to be 2 squared, minus 4, a being minus 3, and c being minus 5. And let's see if this is less than 0. Now using a calculator, we have 2 squared, which is 4, minus, now we have minus 4 times minus 3 times minus 5, which is minus 60. And is that less than 0? 4 minus 60 is minus 56, which is less than 0. Therefore, there are no real solutions. To this quadratic. And therefore we can conclude that y equals plus or minus root 2 are the only two real solutions. And that's it for this question. Now in terms of the marking, you'll get 1 mark for deducing that there are no real solutions to this quadratic, and you'll get 1 mark for finding the two real solutions to what y is, and that's a total of 2 marks for this question. Now that part B is over, we move on to part C. Deduce the number of real solutions for this range here, theta between 7 pi and 10 pi, to this equation here, this cubic and tan theta, 3 tan cube theta minus 8 tan squared theta plus 9 tan theta minus 10 equals 0. Well, first thing to do is look how strangely similar this is to what we had as f of x. If I write down what f of x was, it was minus 3x cubed plus 8x squared minus 9x plus 10. And now, if that is the case, then let's use the substitution x equals tan theta and see what we're left with. Now, if we use x equals tan theta on this equation here, we're left with 3x cubed minus 8x squared plus 9x minus 10 equals 0. And now, if we times both sides by minus 1 here, so we have minus 3x cubed plus 8x squared minus 9x plus 10 equals 0, we're left with what f of x is. And now we know how to factorize and solve this from earlier parts. Now from the earlier parts, we know that the only solution to this equation is x equals 2. And now we need to find out the values for theta in that range. So what we're really trying to find out is when tan theta equals 2, for that given range, how many solutions do we end up with? Well, the first thing to do is let's draw a cast diagram to help us out here. Now, how a cast diagram works is we label it as C-A-S-T, spelling out cast. Now in this bottom right quadrant here, the C stands for cos, so this is when cos is positive. The A here stands for all, and that's when all the trigonometric values, cos, sine, and tan, are positive. The S stands here for sine, when sine is positive. And lastly, the T here stands for tan, for when tan is positive. Now, tan theta here is positive, which means we have this quadrant and this quadrant to look at. And now, let's find out what inverse tan of 2 is. So, tan theta equals 2, then inverse tan of 2 is going to be, and we're in radians here, so be careful with your calculator, gives us 1.107, etc. So we're going to have one solution there, 0.107, etc. Another solution there, 1.107, etc. So that's going to be pi plus that solution. Now, we need to choose the number of real solutions, not actually conclude what the solutions are. Now, another thing to mention is that the number of solutions in the given range that we have here, 7 pi, theta, and 10 pi, is the same in the range of 0, theta, and 3 pi, as the amount of turns we have around are exactly the same.
And the reason this works is because to get from 7 pi to 10 pi, it's a difference of 3 pi, which is 1.5 periods. And the difference between 0 and 3 pi is also 3 pi, which is still 1.5 periods. So the number of solutions in each of them will be exactly the same.
So what we really need to find out is the number of solutions in this range here. So in this range here, we have 1, which is that first one there. Then we have another one here, and that takes us 2 pi round. But we need to go around 3 pi, so that's 1.5 turns. So in that 1.5 turns, we hit this one again for the second time. So therefore, we have 3 solutions there. So our 3 solutions would be theta equals 1.107, etc. 1.107 plus pi, and 1.107 plus 2 pi. And therefore, we can conclude there are 3 solutions. And that's it for the question. In terms of the marking, you'll just get 1 mark for proving that there are 3 solutions for what theta is. And that's it for this question, it's just 1 mark.